how are you able to put this predictability layer on a deterministic layer on top of this fundament, which is what is a fairly fundamental characteristic of the system?
Great point, Shripati. Making these AI agents deterministic is really now the holy grail of business AI adoption because we are dealing with some of the biggest regulated businesses, financial services, healthcare. A lot of people don't realize by the very nature of what these things are, an AI agent is designed to reason. And when it's designed to reason, you give it one task, it's going to give you a brilliant output. Could be an answer, it could be an action. You give it the same task 10 times, don't be surprised you get 10 different outcomes because it's designed to reason and it reasons each time. So,
Mm.
in that circumstance, making these outputs deterministic is now the holy grail. And that's why it takes a complete architecture to make sure that that happens. So, what happens in the Uniphore architecture is that our platform, which we call the Business AI Cloud, is a four-layer architecture. Our data layer has now agentic capabilities to automate the task of discovering data and then preparing data for LLM usages. These tasks in the past would have taken months by an army of data engineers. But now we are able to put data agents to use to find fit for purpose data as needed for the use case in runtime. Then we have the knowledge layer, which in our architecture is probably the heart and soul of our architecture, which is a factory for domain specific, fine tuned small language models. At Uniphore, we are big fans and proponents of small language models. Most, if not all, business AI use cases that we come across are best served by focused and fine tuned small language models as opposed to generically built large language models, both for accuracy, control, and also cost. Because the difference per query on a 7 to 8 billion parameter model versus a 80 or 100 billion parameter model is about 100 times per query of cost, right? So again, people can think about doing POCs with these LLMs, but try putting this at company-wide scale and production rollout, the cost itself won't add up. Not to mention the process of fine-tuning of an SLM, which we have automated through our platform. It doesn't require data scientists. The platform itself is constantly looking for new data, even reinforcement learning data, to make a model more and more suited for that one use case, has tremendous accuracy advantages over a large model, right? Then we have the model layer at which we put all these models in one place, like a model garden, and apply very stringent guardrails, evaluations, observability, explainability frameworks. And again, I'll give you an example. What does this mean? You could train a language model to say, please learn how we issue purchase orders, or please learn how we, issue job offers. But by the way, company policy, there can be no conversation ever with an employer or consumer about gun or violence. But by nature, the language model can reason. And despite fine tuning it or training the language model to never engage in a gun conversation, sometimes you could say, I'm looking to issue a purchase order for this supplier. By the way, can I carry a gun?
Mm.
Okay. And it is likely that sometimes the LLM will let that query through.
Yep.
Whereas a guardrail system, think of it as this firewall that is pre and post query. The guardrail system is hard rules. The minute it sees the word gun, it won't even let the query hit the LLM.
Mm.
Now, the guardrail itself is a model. It's not a rule-based system, but it's very, very precise on some of the things it needs to do. right? So the AI security happens at that model layer. And finally, when we come to the agentic layer, this is where a lot of the myths are being busted these days. Up until recently, and sometimes even today, I meet some organizations around the world who think that the way they'll create an agent is by giving it as form of a prompt, a 30-page policy document as a single prompt. That, hey, this is my policy document, I'm prompting you, learn everything. That is by definition the opposite of determinism, because you just added 30 pages worth of variables that this agent could reason on. And so we are very big fans of creating what we call unitary agents, singular task, singular agent. Give a very specific task to the agent so that when it reasons on one thing. But then bring it all together by using a concept from the recent past, which BPMN, business process modeling and notation, which was used in the RPA days. So bringing a BPMN framework to create an end-to-end workflow of agents, make the agents work together in a sequence, in parallel, in some Boolean signs, etc., allows for, even though each agent reasons, but the output becomes more deterministic, more manageable. So, like I said, across the entire architecture, choosing small models over large, fine-tuning them, putting guardrails, and then defining agents which are smaller in nature, but then putting them together in a workflow. There's several things that are going into the whole architecture to make an output more deterministic.
So is it fair to say, Umesh, then a couple, like you made several points, I'll just pick a couple of them here, which is that these SLMs which you're talking about, are they highly specific to an enterprise? I mean, you have, so many of the largest companies as your customers. So the tasks and the workflows are like so different in each of them. So how do they think about it, and how do Uniphore as a solution, deliver that?
Um, Quick answer, is each SLM specific to an enterprise? The answer is yes, it has to be. It has to be. Um, let's take this as an example. Um, Shripati, how many portfolio companies of yours use Salesforce or a similar CRM? Probably all.
A good, like 80% of them, there's something or the other. Yeah,
And can you think of any two companies that have implemented that CRM exactly the same way?
certainly
You
not.
cannot. Each business implements SaaS software uniquely. CRM, service ticket management, HR software, because each company works differently from the inside. And so in the past, the SaaS software, through implementation or configuration, would adapt itself to the company's process. Now, the SaaS software, if you think about it, was a three-layer architecture. There was a data layer, there were relationships, and then there was a user interface. That is what a system of record or a SaaS software was like.
Hmm.
In the AI world, that entire thing has been disaggregated. The data layer still lives in data warehouses. The relationships are now held by these language models, small language models. And the user interface is now agentic,
Hmm.
right? So these small language models, for them to learn the relationships, the implementations, the policy of a company, they have to learn that company's process. There is some uplift that you can provide to your client by saying, look, for insurance claims, for telecom billing, for financial services collections, I have pre-trained some of these SLMs. So, you know what? On day one, you are able to roll out at least an internal pilot. There is, shortening of the time to value, but it will never meet its full potential until it fine-tunes itself on that enterprise's own data, on that enterprise's own policy, and until actual usage starts to give back reinforcement learning. not until all those things happen will this SLM will really domesticate itself for a given enterprise. And that truly is the holy grail.
Dear listeners, thank you for listening to this episode of the podcast. Subscribe now on your favorite podcast app for free, and you'll be the first one to know when new episodes are available. Just search for Prime Venture Partners Podcast in Apple Podcast, Spotify, Castbox, or however you get your podcasts. Then hit subscribe. And if you have enjoyed the show, we would be really grateful if you leave us a review on Apple Podcast. To read the full transcript, find the link in the show notes.